Next up is Dr. Heather Schneider. She's the lead rare plant biologist at the Santa Barbara Botanic Garden, where she works collaboratively to tackle rare plant challenges from the genetic to the ecosystem level. Heather is one of the most capable people that I know, whether it's trekking the backcountry, herding cats on her big collaborative projects, or serving as sommelier when you don't know which wine to pick. She'll be speaking about the conservation gains achieved over the last 4 years through a major collaborative project to recover 14 island rare plant species on 7 of the 8 Channel Islands. Stay close.
Hi, thanks. I have the great privilege of getting to know the islands while they were already in their period of recovery and being able to work off of the immense foundation that you've heard about from everyone who came before me today and throughout the many, many decades of work on the islands. So today I'm going to tell you a story about a project that many people in this room and outside of it have worked on for the last 4 years. I want to stress, like everybody else, that this was a huge collaborative effort, and we had partners at the federal government agencies, other nonprofits, the military, and all of this work was funded through a clause in the Federal Endangered Species Act, which is pretty neat, that says that the federal government will spend funding for the states to help recover their rare listed plants. And the goal of this project sounds simple, but was very complicated. We wanted to assess and assist the recovery of 14 listed plants on the Channel Islands. And we focused on 7 of the 8 islands, which sounds a little bit silly, but we worked on the 4 northern islands, San Nicolas, Santa Barbara, and Santa Catalina. San Clemente has a very well-funded conservation program, and we partner with them in other ways, but in this case, they decided to let us disperse the funding we had across the 7 islands, and they kind of did their own thing. And the 14 listed plants that we worked with ranged from diminutive annual wildflowers, many of which only occur on one island, like the slender-flowered gilia, the island phacelia, and the Santa Cruz Island lacepod. We also worked on herbaceous perennials like the Hoffman's rockcress, the softleaf paintbrush that Catherine just spoke about, beach spectacle pod, and 2 endemic Dudleya taxa. And then we had 2 shrubs, which you've heard a little bit about from others as well, the Santa Rosa Island manzanita and the island barberry. And in order to tackle 14 listed plants across 7 islands, we had to do things sort of in a systematic, stepwise fashion. And that started with surveys, just getting out on the islands, pounding soil, flying in helicopters, which is very fun, and getting to know where these plants are, how many of them are there, and how are they doing. To do this, we used mapping protocols, which are kind of boring for regular people, but super fun for nerds like me, because we wanted to do this in a repeatable way. We were laying the foundation for ourselves and whoever comes after us to understand how these plants are changing over time. Our genetics team in the garden did a study of the island rush rose, which occurs on Catalina, Santa Cruz, and Santa Rosa islands, to understand how the plants on those different islands are related to each other, which could guide future management decisions. And we did a lot of seed collecting. We brought a lot of seeds into our conservation seed bank at the garden, which, as Denise mentioned at the beginning of the program, is our insurance policy against extinction. We also brought some plants into the garden's living collection, which is another way that we can not only share these plants with people who can't get to the islands themselves, but also to preserve those genetics within our garden as living plants. We used a lot of our seeds and some wild cuttings to propagate plants so that we could create the resources we needed to do restorations and reintroductions to try to put more plants in more places back on the islands. And then that was the last step, a lot of what Catherine was talking about, but usually with rare plants, it's on a much smaller scale. We didn't roll miles of wattle. We made 30 by 30 centimeter plot frames and put a few seeds in where we could. And to give you an idea of the scale of the groundwork that we did here, this is a map of Santa Cruz Island, and each of these points and triangles is a touch point that someone working on our project encountered rare plants. And on Santa Cruz Island, that meant the Santa Cruz Island Live Forever, the island rush rose, Hoffman's rock cress, the Santa Cruz Island lace pod, the very, very, very tiny Santa Cruz Island Malacothrix, which is that tiny yellow dot next to the pen, and the island barberry. And this was just on one island, by foot and by air. Across all 7 of the islands that we worked on, our team made 540 rare plant observations. That's 540 individual touch points for where we saw and collected information about rare plant populations, which created a really powerful data set building on what we knew from before this project to help us understand the status of these plants and what we can and should do next to help them recover. And some of our observations were really exciting. So we found 5 new populations of Hoffman's rock cress on Santa Cruz Island, which was significant in multiple ways. First of all, because we realized this plant is doing better than we realized it was, which is always good news when you work on rare plants. But also we learned that it could occur in habitat types that we didn't previously know it lived in. And so this totally changed the way that we look for this plant now, and it extended into how we look for it on Santa Rosa Island, and this information helped us to find 1 new patch there. And we plan to continue these surveys to see if we can find additional populations. The Santa Barbara Island Live Forever has quintupled in numbers that we know about as humans since 2011. And this is due to the long-standing effort and dedication of the National Park Service and CIES, and the fact that they were able to employ aerial surveys. So we were able to get more accurate counts of Dudleya, which like to live on rugged, craggy cliff faces that people can't easily traverse. And so that was a really big boon for this plant to understand that there was a lot more of it than we realized on the landscape. And as Catherine mentioned, the Santa Cruz Island Live Forever we found throughout this project had expanded in both numbers and extent. And this was building on decades of monitoring work that had been done by lots of folks over the years. And as she mentioned, the exclamation point on this is that now, because we were able to get this data and understand how this plant is doing and its trajectory looks positive, now it's proposed for delisting from the Federal Endangered Species Act, which isn't something that happens every day. So for people like us in conservation, that's just a huge win that feels really good and shows us that when we take the time to look and watch and manage what we can, that we can really make progress. Again, by getting boots on the ground, we found 6 new Santa Cruz Island lace pod populations on Santa Cruz. This also was a game changer for us. This was a plant we were all very concerned about. It also grows in really rugged, rocky areas that are hard to get to. And this sort of made us stop in our tracks and say, okay, we thought what we were going to do next is start outplanting new populations because this plant needed it. But now we realize what it really needs is for us to look more and in more places. So that's our next step now. We're also doing seed banking so that if we realize we want to put more plants on the landscape, we can do that. But first, we need to just keep looking. And our partners at CIES grew and installed more than 1,000 Santa Barbara Island Live Forever plants on Santa Barbara Island, which was a huge increase for that population, and they continue to take care of those plants. And something that was really exciting for me and a lot of the partners on the project is that the island Malacothrix, which theoretically occurs on Santa Cruz and Anacapa Island, although no one's seen it on Anacapa for some decades. We were able to bring seeds of that plant into our conservation seed bank and grow it in our nursery to make more seeds to use for restoration in the future. John Knapp, our partner at Nature Conservancy, every year would go to the population where this plant grows, collect seed, and it occurs with that tiny little other Malacothrix, so it can be really hard to tell who's who when they're just in seed and the stems are all dry. And every year we would put those seeds in the nursery, water them, and pray that island Malacothrix would reveal itself. And when it finally did, it was just a magical day. And now we've grown thousands of seeds from this plant, so we're ready to really help it out and start doing seeding efforts on the island. And on the topic of that, just in the garden nursery for this project, we grew 8 different island plants, mostly annual wildflowers, and produced nearly 500,000 seeds that can all be used for these restoration seedings, outplantings, and reintroductions if needed. And this was really great because not only are we creating the resources that we need to push conservation and recovery forward, but we're also learning about these plants and about their life cycle and how to grow them and how to germinate them. Because if you've ever tried to grow native plants from seed, they don't always do what you want. I like to say that native seeds are skeptical. They're trained to not believe that it's a good year, so they don't germinate at the drop of water. And the other thing we had to do is to facilitate pollination. Because we want to be really careful about preserving the genetic integrity of these wild populations, we kept them in insect-excluding tents, so each population was isolated from one another so that we didn't have any unintentional gene flow, which meant that me and my team put on our little bee suits, armed ourselves with paintbrushes, and hand-pollinated thousands of flowers over many years to produce those many hundreds of thousands of seeds. And in this tent, if you look closely in the kind of mid-corner, you'll see a mason jar that has a lot of little black bodies in it, and those are flies. We have embraced flies as friends, and they move around the tents, and they are not pollinators in the way that they're looking for nectar or pollen to eat. They're just busybodies, and so they move pollen around incidentally as they flit from plant to plant, and that helps us because when you have a tent with so many flowers and then you have a dozen tents that look like this, it can be hard to keep up with the pollination, so there are little sidekicks for this. And then again, thinking about that insurance policy against extinction, throughout the course of this project, we brought 137 collections of seeds from both wild and nursery-produced plants into our conservation seed bank at the garden. So this is a long-term genetic backup for all of these wild plant populations so that should anything happen in the wild, we can replace them with the seeds that we have. We also, because we were on the island so frequently, we were afforded the opportunity to seed bank 4 rare island deadly taxa that had never been seed banked in the history of people seed banking in California. And even though they weren't all the target of this particular project, just by virtue of being out there, we had access to do something like this. So we had reached beyond just our target species. And we did bring, as I mentioned, some plants into the garden's living collection for long-term conservation that way. And then next steps for this work, as everyone's mentioned, you're never done, you keep doing it. We all have great job security in that way. We recently, as a collaborative group, put together a new proposal looking at 2 species that we feel like are on the brink of recovery. Catherine just mentioned the Santa Cruz Island bush mallow and the Hoffman's rock cress, which we found so many more plants of on Santa Cruz Island. And then we also have a suite of plants that we worked on from this study and all agreed that they're really in need of emergency help here for their recovery. And that's the island barberry, the island malacothrix, the Santa Cruz Island malacothrix, and the island phacelia. So we've put in a new proposal to keep working on these plants and use different strategies to help push them over the finish line. And then, of course, we'll continue to work with our partners across the archipelago. And now I think I have a moment to give you a bonus 15th plant. This is the Santa Cruz Island rock cress, Sabara filifolia. This is a diminutive, depending on the year and how much rain we got, diminutive annual wildflower in the mustard family. This is a federally endangered plant, and for the last year, we're now in year 2 of this project, we've been working with a slew of partners shown on this slide to conduct extensive surveys across Catalina Island for this plant. It was originally described from Santa Cruz Island, but hasn't been seen there in almost 100 years, and right now it's known to occur on Catalina and San Clemente Island. So we worked with our partners at Urban Wildlands Group to create a habitat suitability model, and it won't go through the details, but the basic idea is to take what we know about where the plant grows and then use that to extrapolate to where we think it might be able to grow across the island. And if you look at this map, all of those pink squiggles are tracks of where people on our team have done ground surveys for Sabara filifolia. The green triangles are places where we found Sabara in 2020. What year is it, guys? 2022? I'm like, when was last year? And those orange circles are historically known locations for Sabara. So you'll see that there are a few places where it had been seen previously where we didn't find it last year. But this year we've started our surveys again, starting in early 2023, early February, and we were looking for this. So lest you think my job is all fun and not hard, we're looking for teeny tiny little Sabara seedlings, but some of them were about an inch tall, so I can't complain too much. But the good news is with the rainfall this year, we're seeing an order of magnitude more plants than we did last year, which is really encouraging. And we also found plants in some of those orange circles where we didn't see them last year. And so this is sort of exemplary of why we need these long-term, multi-year projects, is because things change from year to year. The precipitation's different, and the plants respond accordingly. So this work is ongoing with our partners, and a lot of it is in the service of thinking about how and when to try to reintroduce this plant to Santa Cruz Island. And that's all I have for you. I'm happy to take any questions.
In the very beginning, you mentioned you were doing the genetics of a plant that you wanted to find out whether it was on multiple islands, was it?
So the question was, when she talked about doing genetics on the plants, you wanted to find out if it was on multiple islands.
Yeah, so the Island Rush Rose genetic project was done by two of my collaborators at the Botanic Garden and the genetics lab, and we knew it occurred on all three islands, but what we wanted to know was how they were related to each other. And what their study showed is that the plants on Catalina Island are very genetically unique compared to the plants on Santa Cruz and Santa Rosa. And that makes intuitive sense because especially when you're on the west end of Santa Cruz, you feel like you could swim, somebody can swim, not me, to Santa Rosa Island. But those two islands, the plants are pretty closely related. And the way that we can use that information is that if, for example, something happened to the plants on Santa Rosa Island, we could feel pretty comfortable moving seeds from Santa Cruz to Santa Rosa. But usually in the spirit of keeping all the pieces, we also try to keep all the unique genetics. So we would be less likely to take seeds from Catalina and bring them up to Santa Rosa, for example. So thank you.
I think we have time for one more.
Oh, we have time for one more.
You want to field it? One more question. If they...
Yes, John.
What would you say is the greatest threat to all these plants?
What would I say is the greatest threat to all these plants? I think that the greatest threat to all these plants is not putting enough resources toward helping them. That's my honest answer.